Good day classmates! Ang topic ko ay tungkol sa spectroscopy. Sa reporting na ito, ipapakita ko kung paano ginagamit ang spectroscopy sa pag-aaral ng mga molecules at kung paano natin ito mas maintindihan gamit ang mga sample problems. Spectroscopy is the study of how matter interacts with electromagnetic radiation. Ang electromagnetic radiation ay gaya ng ilaw o energy waves. Ibig sabihin, tinitingnan dito kung paano naglalabas o nagre-reflect ng light o energy ang isang substance para makilala ang composition o properties nito. Next, it allows scientists to identify, masukat kung gaano karami, and analyze the structure of molecules. For example, sa medicine, ginagamit ang spectroscopy sa blood test para makita kung gaano karami ang glucose o cholesterol sa dugo. In astronomy, kapag tumingin ang scientist sa light galing sa stars, gamit ang spectroscopy, malalaman nila kung anong elements like hydrogen or helium ang meron doon kahit sobrang layo. In chemistry, kapag gusto malaman kung anong substance ang nasa isang unknown sample, ginagamit ang spectroscopy para i-check kung anong molecules ang present at gaano karami. Next, the different types of spectroscopy is ultraviolet visible spectroscopy, infrared spectroscopy, nuclear magnetic resonance spectroscopy, mass spectroscopy, fluorescence spectroscopy, atomic absorption spectroscopy. So, bawat spectroscopy technique may sariling specialty. Kapag pinagsama-sama, nagiging mas kumpleto ang picture ng identity, quantity, at structure ng compound. Next is the importance of problem solving in mastering spectroscopy. First is theoretical to practical. So, hindi sapat na alam lang ang theory ng spectroscopy. Kailangan itong ma-apply sa totoong problems through problem solving. Natututo kang i-connect ang formulas, principles, at instrument behavior sa real data. Next is second is critical and analytical skills. Ang spectroscopy ay hindi lang basta basa ng numbers o peaks. Kailangan ng critical thinking. So, pagtatanong bakit ganito ang resulta, at analytical skills, paghahanap ng pattern at logic sa data. Third is spectroscopic mastery. So, hindi sapat na kabisado lang ang definitions. Ang tunay na mastery ay nakikita kapag kaya nang gumamit ng iba't ibang techniques together to solve unknown compounds. Next is the objectives of this problem set. So, apply core spectroscopic theories. Second is practice calculation-based problems. Third is to develop skills in integrating complex spectra. Fourth is to prepare for real-world analytical challenges. Next is the electromagnetic spectrum. The electromagnetic spectrum is comprised of all frequencies of electromagnetic radiation that propagate energy and travel through space in the form of waves. Ang electromagnetic spectrum ay binubuo ng lahat ng frequencies ng electromagnetic radiation. Ibig sabihin, ito yung iba't ibang uri ng energy na naglalakbay through space in the form of waves. Kasama dito yung radio waves, microwaves, infrared, visible light, ultraviolet, X-rays, at gamma rays. Longer wavelengths with lower frequencies make up the radio spectrum. Ibig sabihin, sa electromagnetic spectrum, yung mga waves na mabagal ang vibration at mahaba ang haba ng alon ay tinatawag na radio waves. For example, ginagamit natin ito sa radio, TV signals, at cellphone communication. Next, shorter wavelengths with higher frequencies ay bumubuo ng optical spectrum. Sa loob ng optical spectrum, may visible spectrum, which is red to violet, na nakikita ng mata. Tinatawag na optical kasi ito yung range ng electromagnetic spectrum na pwedeng gamitin sa optical instruments tulad ng lens, microscopes, telescopes, at cameras. Next, the portion of the spectrum that we can see is called the visible spectrum. So, nasa utilizes a number of tools that allow us to communicate and create images utilizing almost every single component of the electromagnetic spectrum in one way or another. So, yung part ng spectrum na nakikita ng mata natin ay tinatawag na visible spectrum. Pero gumagamit ng iba't ibang tools para makipag-communicate at gumawa ng images gamit halos lahat ng bahagi ng electromagnetic spectrum. So, hindi lang yung visible light. Halimbawa, gumagamit sila ng radio waves para sa communication sa spacecraft, infrared para makita ang init ng mga bagay, X-rays para pag-aralan ang high-energy objects gaya ng black holes at iba pa. So, ang electromagnetic spectrum ay lahat ng uri ng radiation mula radio waves hanggang gamma rays. Ang nakikita natin bilang visible light ay maliit na part lang nito. The next fundamental principle is the Beer-Lambert law. It describes the relationship between a solution's absorbance of light and its concentration path length and molar absorptivity. So, ang Beer-Lambert law ay nagsasabi ng absorbance ng isang solution ay directly proportional sa concentration nito. Ibig sabihin, kung mas maraming molecule sa solution, mas maraming light ang ma-absorb nito. Ang formula ay A is equal to E times B times C. So, A ay absorbance, E ay molar absorptivity o gaano kalakas sumipsip ng ilaw ang isang substance. B ay haba ng daanan ng ilaw sa solution. C ay yung concentration ng solution. So, for example, kung mas concentrated ang juice, mas dark ang kulay, and kung mas dilute, mas light ang kulay. Ganito rin ang principle sa spectroscopy. So, for its key concepts, absorbance is directly proportional to concentration. Ibig sabihin, habang tumataas ang concentration ng analyte sa solution, tumataas din ang absorbance. So, kung doble ang concentration, doble rin halos ang absorbance. So, it works well at low concentrations. Typically, the absorbance is between 0.1 to 1. So, the optimal range, mas accurate siya kapag nasa 0.1 to 1 yung absorbance. Kapag masyadong mababa, less than 0.1, halos walang signal. And kapag masyadong mataas, which is greater than 1, masyadong humihina yung ilaw na dumadaan at nagiging unreliable yung reading. Next is deviations occur at high concentrations due to scattering interactions or instrument limitations. Pag sobrang concentrated na yung solution, nagkakaroon ng interference wherein pwedeng mag-scatter ng light, mag-interact yung mga molecules or limited na yung kakayahan ng spectrophotometer kaya hindi na straight line yung graph. Next is the basis of quantitative UV spectroscopy for determining unknown concentration of analytes. Ito yung ginagamit sa quantitative UV spectroscopy, ginagamit para makalculate ang unknown concentration ng isang sample gamit yung absorbance at calibration curve. Next is the applications in practice of UV visible spectroscopy. First is determining DNA and RNA concentration of 260 nanometer. Kapag nag-absorb ng light sa 260 nanometer, doon nasusukat ang nucleic acid. So, gamit ito ng mga researchers para malaman kung gaano karami ang DNA or RNA sa sample nila. Next is protein quantification, 280 nanometer or using Bradford BCA assays. So, proteins usually absorb sa 280 nanometer dahil sa aromatic amino acids. Pero minsan gumagamit din ng colorimetric assays gaya ng Bradford or BCA para mas accurate ang measurement. Next is drug concentration monitoring. Sa pharmacology o medicine, ginagamit ang UV visible spectroscopy para makita kung gaano kataas ang concentration ng isang drug sa blood o solution. So, important ito sa dosage at monitoring and research. Next is the sample problems by technique in UV visible spectroscopy. So, ang UV visible spectroscopy ay gumagamit ng UV at visible light para sukatin ang absorbance. Ginagamit sa quantitative analysis ng DNA, RNA, proteins, and drugs. So, problem number 1. A solution of compound X has an absorbance of 0.65 at 320 nanometer. The path length of the cuvette is 1 cm and the molar absorptivity is 2.5 times 10 raised to 4 L times mol raised to -1 times centimeter raised to -1. What is the concentration of compound X? So for the given, absorbance is 0.65, which has no units. Wavelength is 320 nanometer, which is information lang, so hindi ginagamit sa formula mismo. The path length is 1 cm. The molar absorptivity is 2.5 times 10 raised to 4. So in solving this, step 1 is to substitute the value. Step 2 is to solve for C. Step 3 is calculation. Then the final answer is the concentration of compound X is 2.6 times 10 raised to -5. So gamit ang Beer-Lambert law, alam natin na ang absorbance ay directly proportional sa concentration. Problem number 2 is the effect of dilution on absorbance. A sample has absorbance of 1.2 in a 1 cm cuvette. So you dilute it 1:5. So 1 part sample plus 4 parts solvent. What is the new absorbance? So ang dilution factor ay 1/5 or 0.2. So meaning yung concentration ng sample after dilution is only 20% ng original. So dahil dinadilute ang solution, bumababa yung concentration ng analyte. Since directly proportional absorbance sa concentration, bumababa rin ang absorbance by the same ratio. Kaya mula sa 1.2 naging 0.24 lang after dilution. So kapag dinilute ang solution, mas konti ang molecules, kaya mas konti rin ang sumisipsip ng ilaw, kaya automatic bumababa ang absorbance. So example, kung ang soft drink ay matamis sa pure form, kapag dinilute mo ng tubig, mas less ang tamis, ganun din sa spectroscopy. Problem 3 is to identify which has longer wavelength of maximum absorption. Which compound would you expect to have a higher bathochromic redshifted wavelength of minimum absorption? The benzene or transstilbene. So step number 1 is to recall the principle. The wavelength of maximum absorption in UVBs is related to the energy gap between HOMO and LUMO. Ang HOMO, ito yung highest occupied molecular orbital. Ito yung pinakamataas na energy level na may electrons. Then LUMO, ito yung lowest unoccupied molecular orbital. Ito yung pinakamababang energy level na walang electrons, which is empty orbital. So kung mas malaki ang energy cap ng HOMO to LUMO, kailangan ng mas mataas na energy light, which is shorter wavelength in the UV region. So mas maraming conjugation is mas maliit ang energy gap. And mas mababang energy light ang kailangan, and mas mababa ang wavelength. Step number 2 is to compare the structures. So benzene has 6 pi electrons in a cyclic conjugated system. Transstilbene has 2 benzene rings connected by a carbon double bond, giving an extended conjugated system. The pi system spreads over more atoms. Ang pi system ay yung buong network ng pi electrons na pwedeng mag-delocalize. Sa benzene, limitado lang sa isang ring, pero sa transstilbene, mas mahaba ang conjugation kasi may 2 rings na connected sa carbon double bond. Kaya mas extended ang pi system ng transstilbene, which is mas maliit ang HOMO to LUMO gap. So, mas mataas ang wavelength of maximum absorption. So, step 3 is prediction. So, mas conjugated ang trans-stilbene kaysa benzene. Kapag extensive ang conjugation, mas mahaba ang wavelength of maximum absorption. Mas maliit ang energy gap. So, mas mababang energy light ang kailangan. Mas mababang wavelength. Kaya, trans-stilbene absorbs at longer wavelength kaysa benzene. Next is the IR spectroscopy or infrared spectroscopy. Ang infrared spectroscopy ay parang fingerprint ng molecules. Ang bawat band tulad ng oxygen to hydrogen, carbon double bond oxygen, at nitrogen to hydrogen ay may sariling frequency kung saan ito sumisipsip ng infrared light. So sa left side, the molecular dance with light, spectroscopy, IR spectroscopy basics. So molecules are in constant vibrational motion. Ang mga molecule hindi steady. Lagi silang nagba-vibrate, meron stretching, bending, twisting ng bands. Next, if IR energy matches specific band frequencies. Kapag tumama ang infrared light at tugma yung frequency nito sa vibration ng isang band, ma-absorb ang energy. Next is absorption occurs when frequencies resonate. So, resonance, ibig sabihin, match yung vibration ng band sa energy ng IR. Dito nagkakaroon ng absorbance peak. So, each band has unique vibrations. Halimbawa, carbon to double band oxygen, oxygen to hydrogen, at nitrogen to hydrogen na may kanya-kanyang frequency. Sa right side naman, functional group fingerprints. Specific functional groups absorb at defined IR region. So, bawat functional groups, meron silang signature na absorbance sa spectrum. Next, this cause distinctive peaks in spectra. Kaya may mga sharp dips, peaks sa graph ng IR spectrum. Next, it acts as a molecular identifier for structure elucidation. So, dahil unique ang absorption pattern ng bawat molecule, pwede itong gamitin para makilala o makonfirm ang structure ng compound. So, sa IR spectroscopy, parang sayaw ng molecules ang nangyayaring. Bands vibrate in specific ways. So, kapag tumama ang IR light na sakto sa vibration frequency ng isang band, mag-a-absorb siya at lilitaw bilang peak sa spectrum. So, dahil bawat functional group may unique vibrations, nagiging parang fingerprint ito ng molecule, which is useful sa pag-identify ng compounds. Next, problem number 1 sa functional group identification. An IR spectrum shows strong peaks at 1,715 cm raised to -1, broadband from 2,500 to 3,300 cm raised to -1, and sharp peaks around 12,000 cm raised to -1. So, which functional groups fit best? Example of functional group ay hydroxyl, amines, alkanes, alkenes, alkyne, carbonyl, carboxylic, esters, and ethers. Step 1 is to look at the carbonyl region, which is 1,600 to 1,800 cm. So, yung 1,715 cm, it is a classic carbonyl stretch. So, carbon-oxygen double bond stretch. Ibig sabihin, may functional group na mayroong carbonyl band tulad ng aldehyde, ketone, ester, amide, o carboxylic acid. So, step 2, check for oxygen-hydrogen band or nitrogen-hydrogen stretch. Nakakita ang very broad band mula 2,500 to 3,300 cm. So, ang ganitong sobrang lapad at pababa na band ay classic para sa oxygen-hydrogen stretch ng carboxylic acid. Hindi ito tugma sa alcohol na mas nasa 3,200 to 3,600 cm at mas malinaw ang shape o sa amay na mas makitid at nasa 3,300 cm. Kaya malakas na indication ito ng carboxyl group. Step 3 is to check for carbon and oxygen single bond stretches. So, ang sharp peaks ay sa paligid ng 1,200 cm ay consistent sa carbon to oxygen stretching vibrations. Dahil ang carboxylic acid ay may parehong carbonyl bond, carbon to oxygen double bond, at carbon to oxygen single bonds, tugma ito sa pattern. So, ang final answer is the functional group is carboxylic acid. So, problem number 2, hydrogen to hydrogen versus oxygen to hydrogen. Iko-compare yung band sa IR spectrum ay mas tugma sa nitrogen to hydrogen band stretching o sa oxygen to hydrogen band stretching. An IR shows a broad strong band centered 3,400 cm but with distinct sharp peaks rather than a very broad envelope, which is more likely a primary amine or alcohol. So, an IR shows a broad, strong band at 3,400 cm with two distinct sharp peaks, not just one very broad envelope. So, step number 1 is to recall oxygen-hydrogen stretching. Kapag alcohol, ang oxygen-hydrogen bond stretching ay lumalabas sa 3,200 hanggang 3,600 per centimeter. Kadalasan itong broad at smooth. So, isang malaking malapad na hump. Broad siya kasi ang hydrogen bonding ay nagbabago-bago depende sa environment. Kaya nagmi-mix ang vibrations at nagiging parang malapad na balon ang itsura. So, usually, isa lang yung hump, hindi hati sa dalawang matutulis na peak. Number 2 is to recall nitrogen to hydrogen stretching. So, kapag primary amine, may dalawang nitrogen to hydrogen bonds, may dalawang matutulis na peak sa 3,300 hanggang 3,500 per centimeter. Dahil ito sa symmetric stretching at anti-symmetric stretching at ng dalawang nitrogen to hydrogen bonds. Kapag secondary amine, isang nitrogen to hydrogen bond lang makikita mo sa isang sharp peak sa parehong region. And kapag tertiary amine, walang nitrogen to hydrogen bond, walang makikitang peak sa region na iyon. Step number 3 is to compare with spectrum given. Sa spectrum na ibinigay, may dalawang sharp peaks malapit sa 3,400 per centimeter. So, ito ay malinaw na characteristics ng primary amine. So, ang final answer, ang primary amine ay nagpapakita ng dalawang nitrogen-hydrogen stretches, symmetric at anti-symmetric. Kaya lumalabas ito bilang dalawang sharp peaks sa 3,300 to 3,500 per centimeter. Samantalang ang oxygen to hydrogen stretching ng alcohol ay karaniwang mas broad at isa lang ang sa malapad na hump. The next fundamental principle is NMR spectroscopy. So, main concept of NMR is nuclear spin. Kapag ang nucleus ng atom ay may odd mass number o odd atomic number, meron itong intrinsic na spin. So, parang maliit na magnet ang nucleus. Next is external magnetic field. Kapag nilagay ang nucleus sa isang malakas na magnetic field, mag-a-align ito, so either with or against the field. So, habang nag-a-align, umiikot din siya at may specific frequency kung saan ito nagre-resonate. So, ito yung sinusukat sa NMR. Sa key special parameters, chemical shift, ipinapakita kung saan lumalabas ang peak sa spectrum. Depende ito sa local electronic environment ng nucleus. So, halimbawa kung mas shielded or de-shielded ng electrons. Next is the splitting N+1 rule. Ang mga peaks ay maaring mag-split dahil sa interaction ng mga kapitbahay na nuclear. So, rule, kung ang proton ay may n equivalent neighboring proton, sa hatiin ang signal sa n plus 1 peaks. So, halimbawa, kung may 2 neighboring protons, magiging triplet. So, 2 plus 1. So, ang NMR ay paraan para makita ang electronic environment ng atom sa molecule. Ang nucleus, lalo sa hydrogen. So, ay parang maliit na magnet. So, kapag inilagay sa external magnetic field at tinamaan ng radio frequency, nagbibigay ito ng signal. Sa spectrum, tinitingnan kung nasaan ang peaks, so chemical shift, at kung paano sila nag-i-split, which is yung n plus 1 rule, para makuha ang structure ng compound. A molecule with molecular formula carbon 4, hydrogen 8, oxygen, gives the following protonuclear magnetic resonance spectrum recorded in deuterated chloroform. 1.25 parts per million triplet 3 hydrogens, 2.4 parts per million quartet 2 hydrogens, 3.65 parts per million singlet 3 hydrogens. Then propose a structure. So the total integration is 3 plus 2 plus 3 equals 8H, which matches the hydrogen count in both C4H8O and C4H8O2. Ang ganitong klaseng NMR spectroscopy problem ay ginagamit para matutunan kung paano i-interpret ang spectra at makilala ang structure ng isang unknown compound. So ang purpose ng problem ay sanayin kang gumamit ng NMR data para tukuyin ang compound. So, step 1 is to interpret each signal. So, dito, inisa-isa ang bawat signal ng protonuclear magnetic resonance spectrum para makita kung anong functional groups ang meron. So, sa 1.25 parts per million triplet 3 hydrogens, a methyl group that is split by 2 hydrogens, that is a methyl group attached to a methylene group. It is atypical of a terminal ethyl methyl. Next, the 1.25 parts per million triplet na may 3 hydrogens. Ito ay isang methyl group na katabi ng methylene, which is typical sa dulo ng isang ethyl chain. Yung 2.4 parts per million quartet na may 2 hydrogens, ito naman ay methylene group na katabi ng methyl dahil lumabas siya sa medyo downfield, mas mataas ang value. Ibig sabihin, malapit siya sa carbonyl group o ibang electron withdrawing group. Next is yung 3.65 parts per million singlet na may 3 hydrogens. So, malinaw itong methoxy group. Singlet siya dahil wala siyang hydrogen na kapitbahay. So, pag pinagdugtong lahat, merong isang ethyl group, isang methoxy group at clue na may carbonyl group sa structure. Kaya ang pinaka-consistent na compound dito ay isang ester, specifically methyl ethanoate or ethyl acetate. So step number 2 is to propose the most consistent structure. So the pattern strongly fits an ester. Methyl propanoate, also called methyl propionate, structure is called hydrogen 3, carbon, hydrogen 2, carbon double bond oxygen, oxygen, carbon, hydrogen 3. So for assignments, methyl group, which is a terminal of ethyl, corresponds to 1.25 parts per million triplet 3 hydrogens. Methylene group, alpha to carbonyl, corresponds to 2.4 parts per million quartet 2 hydrogens. Methoxy group methyl ester corresponds to 3.65 parts per million singlet 3 hydrogens. Molecular formula of methyl propionate equals carbon 4 hydrogen 8 oxygen 2. Sa step na ito, tinutukoy kung anong structure ang pinakatugma sa lahat. So, ang pattern ng signals ay malinaw na pasok sa ester functional group. Ang structure na pinaka-consistent ay methyl propanoate, tawag ding methyl propionate na may formula na C4H8O2. Dito sa step number 3, napansin ang inconsistency. So, ang binigay na molecular formula ay C4H8O2. Ibig sabihin, isang oxygen lang ang meron. Pero base sa NMR spectrum, malinaw na may dalawang oxygen. So, isa para sa methoxy group, isa para sa carbonyl group. Kaya ester talaga siya at nangailangan ng dalawang oxygen atoms. Kaya ang tamang molecular formula ay C4H8O2, hindi C4H8O. So sa final answer, ang pinaka-consistent na structure ay methylpropionate o methylpropanoate, na ang signals ay sakto sa 1.25 triplet 3 hydrogens, kaya ito ay terminal methyl, 2.4 quartet 2 hydrogens, methylene alpha sa carbonyl, 3.65 singlet 3 hydrogens, methoxy group. Next fundamental principles is mass spectroscopy. So ionization and mass to charge ratio. So ang sample ay ginagawang gaseous ions. Ibig sabihin mga molecules na tinatanggalan ng electrons para maging charge. Pagkatapos, ang mga ions ay hinihiwalay base sa kanilang mass to charge ratio. Kung gaano kabigat sila kumpara sa charge nila. Nangyayari ito sa pamamagitan ng electron bombardment o iba pang ionization methods. Sa process na ito, may tatlong main parts: ion source, mass analyzer, to mass detector. So, kung saan nagiging ion, sinusukat at dinedetect ang mga ion. The molecular ion, ito ay buong molecule pagkatapos mawalan ng isang electron. Ang peak nito sa mass spectrum ay nagpapakita ng molecular weight ng compound. So, ito ang main signal na nagsasabi kung gaano kabigat ang buong molecule. Next, fragmentation patterns. Habang tinatamaan ng electron ang molecule, nababasag ito sa mas maliit na fragments or ions. Ang mga fragment ions ay nagbibigay ng clues tungkol sa structure ng compound. So dahil unique ang pattern ng bawat compound, nagagamit ito parang fingerprint sa pagkilala ng substance. A compound with molecular weight 86 gives a strong molecular ion peak at M/Z 86 and a base peak at M/Z 43, such as a plausible structure. So kung may molecular ion peak sa M/Z 86, ibig sabihin ang buong molecule ay may molecular weight na 86 grams per mole. So ang mga formula na tugma sa mass na iyon include C5H10O2 na isang 5-carbon compound na may isang oxygen. Karaniwan ito ay ketone, ether o alcohol. So step number 2 is interpretation. Ang M/Z 43 ay isa sa nakakaraniwang fragment peak sa mass spectroscopy. May dalawang possible dahilan kung bakit lumalabas ito. So acylium ion, mass 43 din. So, nabubuo kapag may ketone o ester at napuputol ang bond sa tabi ng carbonyl group. Ito ang tinatawag na alpha cleavage. So, common ito kasi stable ang CH2CO4 ion. Next, propyl cation, mass 43. Nabubuo naman ito kapag ether o alcohol ang compound at napuputol ang chain para makabuo ng C3 fragment. So, alin ang mas likely? Dahil ang parent compound ay may molecular mass na 86 at may oxygen at ang base peak ay M/Z 43, mas consistent ito sa isang ketone. So, ibig sabihin malamang na nag-form ito ng acylium ion sa fragmentation process. So, isang signature peak para sa methyl ketones o oxygenated compounds na may carbon double bond oxygen. Step number 3 is to suggest a concrete structure. So, ang pinaka-posibleng compound is 2-pentanone o minsan 3-pentanone. Ang formula nito ay C5H10O at ang molecular weight niya ay 86 grams per mole. Kaya tugma sa given molecular ion peak na M/C is 86. So, structure is 2-pentanone. Ibig sabihin na sa gitna ang carbonyl group, kaya 2 sa pangalan. So, bakit ito tama? So, kapag ketone, tulad ng 2-pentanone ay na-ionize sa mass spectrometer, puputol ng band katabi ng carbonyl group. Ito ang tinatawag na alpha cleavage. Pag nangyari ito, nabubuo ang acylium ion na may M/Z is 43. Ang ion na ito ay stable, kaya ito ang base peak. Ibig sabihin, ito ang pinakamalakas na signal sa mass spectrum. Next, ang pinaka-best na sagot para sa compound na may molecular weight na 86 at may base peak sa M/Z 43 ay isang ketone. So, particular na 2-pentanone. So, ang M/Z 43 ay dahil sa pagbuo ng isang acylium ion. Nabubuo ito kapag naputol ang band na katabi ng carbonyl group. So, tinatawag itong alpha cleavage. Dahil stable ang acylium ion, ito ang nagbibigay ng base peak o yung pinakamataas o pinakamalakas na peak sa spectrum. Next, for the conclusion, spectroscopy ay nagbibigay ng mga makapangyarihang paraan para makilala, masukat at ma-analyze ang mga chemical compounds. So, UV spectroscopy ginagamit para sukatin ang concentration ng substance. Infrared spectroscopy para makilala ang mga functional groups, kung anong klase ng bonds o grupo ng atoms meron ang compound. NMR, nuclear magnetic resonance, nagbibigay ng detailed information sa structure ng molecule. Mass spectroscopy, tumutulong para malaman ang molecular weight at kung paano nagpa-fragment ang compound. So, in spectroscopy, it is a combination ng tools na tumutulong sa atin maintindihan at makilala ang mga molecules mula sa timbang, structure hanggang sa composition.